Alright, welcome back to Stream 19 of Game Development with Unity, 3D Game Development. I'm your host, Johnny Rush, and we are going to go over a few things here. In our last stream, we talked about really moving forward with building or enhancing the HUD, the player HUD. We need to start showing health, stamina, armor, um, rank, experience, gold. We're going to add all that, and as well as quick slots. Now, some of this I already have done. Um, since the last stream, I was working on adding the health icon, and I just finished adding the armor icon here, the blue shield, and I added what I call a quick slot view when you're just roaming around. Um, You've got 6 slots here, and 1 and 2 represent primary weapon and secondary weapon. They'll show up in slots 1 and 2, and then 3, 4, 5, and 6 are the 4 quick slots that are in the player inventory screen. So you'll have anything you put there, you can access those items through the hotkeys. Now the actual use or interaction of those items is not implemented yet. What I'm doing right now is making sure the UI HUD is in place so that we can start working with some of this and writing the script, basically going back to the scripting side and start implementing some of this functionality. So let me show you what I have right now so you can kind of see what it looks like. Yeah, so this is what we have now. Lower left, you'll see there's a red heart. That's our health, and armor, which is the blue shield. They're both set at 100. Later on, I'll implement a way to increase those, maybe like a max increase. But right now, they are set to 100 each. And so when they get recharged, initially it'll just be readjusting those values back up to 100 when we utilize a first aid kit, for example, to bring up the health, or we drink a potion or something that would increase, some kind of drink that would increase our defense or armor. So let me just start picking up some items. As you can see, if we hit inventory, we got our primary pistol, our bat that loaded, and then these are the quick slots here. So whatever items show up here will show in slots 3, 4, 5, 6 on our quick slots, and 1 and 2 is our primary and secondary. So you see as those are picked up, they automatically appear. Now in our inventory, we do have in the top left, it's showing the quantity in each slot. Here it's a little bit different. The numbers represent the hotkey that you'll press to access that, or switch between that quick slot item. So just keep that in mind. Just for easy reference there. Now the other thing I did add, besides just adding the icons on there, the health icon and the shield icon are actually functional. And so the function we went over last time, called take damage. It's in our player script. It takes care of applying damage. Now, before I could do that, one of the things I had to figure out was, besides just doing direct damage, since we don't have any AI enemies right now to be able to inflict damage on our player, the only possible damage that I could see that I could implement right now would be fall damage. And that was something I needed to figure out how to do anyways, how to determine how much we've fallen, the distance we've fallen, and based on that distance apply some kind of method. So I'm keeping it real simple. The calculation I came up with is it just subtracts the when you start falling, the basically the Y value of the player at that point, it's measured in, according to Unity, it's in a meter system. So you start at a certain number of meters as you're falling, and then when you hit the ground, the third-person in-vector third-person controller that we're using has a flag called a Boolean flag called isGrounded, and so that'll be triggered when the player hits the ground and all that. So I had to fool around with some of that. It took me a while to figure that out, but I finally got it working to the point where it'll actually show fall damage. And so yeah, going back to the formula, what I set up was, you know, let's say this is 150 meters up, and we drop and hit that floor down there, and that's at, let's say, 20 meters above sea level, which is our base of our ground, or our you know, island here. So that's a difference of 130. Now I'm subtracting out what I consider a safe distance to actually walk off of certain platforms off a certain height, and that's just 10. I just took 10 meters off. So anything 10 meters, which is essentially the platform that's under us, where you go up the brick stairs up to the lower platform here at the base of this tower. If you walk off that, you might, it's right at about 10. It might show like a half. You know, you might get 10 and a half as the distance from there to the ground, to the green grass under. And subtracting the 10 winds up being like a half a meter of damage, which equates to a half a point of damage taken to the player. Now, what I'm doing is, you know, I created two functions: one to decrease the shield damage or the armor, and one for the health. Initially, I just had the health, so that's what I was working with the other yesterday. And you know, I noticed if you drop off the cliff, like I'll go off the island, off this back side, the south side, and you drop off that cliff, that's 133 to 135 meters down. Subtracting 10, it's still 125 damage, roughly, that you're taking. So the player would instantly die. And even though realistically I'd like, you know, that to be true, because you know that is a pretty steep fall dropping off that edge. You know, I want to make this game where it's playable and you continue on. So that's when I decided to add the what I call the shield or armor, and also this will also be used, you know, if we're taking hits from enemies or another player further on down the road. You'll have some kind of defense system that you can, you know, actually build up and have that, so it'll help defend against that. Anyways, so combined you have about 200 points of damage you can take, 100 between the shield and 100 between your health. And so what I'm going to do is these, I decided to not really do anything with thirst and hunger right now, unless I can come across a potion bottle, which I can use in the inventory system. These blue bottles here are the number that's in slot 5 right now. Basically, it's a water bottle. That'll be used to simulate recharging the armor, and the first aid kit, of course, will recharge health. So now when you take fall damage, like I said, initially I had the heart, so the damage would come directly to your health points, or your health. And when I added the shield, I wanted that would be like your first layer of defense. So you know, I modified the code, the take damage function, that it'll check that if there's you know, any value of shield remaining, it will subtract or apply the damage to the shield first, and then the remaining damage, if any, would then be passed on to the health, or subtracted from the health. So let's demonstrate how that works. I believe when I'm up here, I forgot what the damage amount was. Let's drop down. Okay, we took a little bit because we landed on the stairs. You can see the shield went down. And it's shown in the status bar here if you look down at the bottom. right here. You really can't see it too well unless you're watching it HD. But it says 88.43. It's damage can be a fractional portion because of calculations that are done and with the distance. And so I've set all those up and modified them from being standard integers, whole numbers, to or decimals to floating point. And so you can take fractional damage, 0.5%, for example. So anyways, it looks like we went down to 88.43. So we took a little over 11.5, almost 11.6% damage on that fall. Now, if we didn't go full screen, we had the console window open. I got some stuff logging that shows, some information like the tracks the time to the starting game time when you start the fall, and then the time when you end, like an elapsed time it'll show, and then it'll show the distance, the starting, ending, and the fall distance, and then calculate the total fall distance and come up with fall damage, and then I show like the stats, the current health and shield stats, and then I show it again after the damage is applied. And the armor being the last thing it's logged, that's why it's showing that. You don't see the health. But let's drop off here. You'll see it'll take some more damage. Drops down again. And then if we run off here, took very little damage there. Hold up. Got my little kittens here pulling on my headset wire, the wire to my headset here. That's not good. I don't want them to slice through that wire. And there goes our audio for the stream. Alright, so let me put this up and out of the way so it's not an issue. Bear with me, I'm just going to pin this. I've got to pin this up under here. Okay, so yeah, so that's essentially how it works here. So the changes I've made thus far are adding the quick slot bar, and it'll automatically show those items in the inventory. Oops, I'm going all over the place. So when a frame drops down to 20, it gets a little difficult when you're running fast to maneuver. Yeah, so let me show you. Keep taking damage. I'll show you once the shield's gone, it starts taking away from our health. So let's jump up here. We'll run all the way up to the top, and we'll drop off the back here, and we'll do a leap off, a jump off, so that we make sure we don't land on the stairs. Well, we got a little more damage, not quite enough to sink into our health yet. Let's see if we can jump over this wall. Oh. Alright, so if okay, let's stop this a second. So let me just show you, I'm going to show you the log here. Let's see what was logged on that last jump. Where it says file data here, we're getting a start and end time. So 711 seconds have elapsed, 0.2052, and it was 712. So it really don't show the total time, fall time, but that's the starting time and the ending time for the fall. So you can see there it's like about a second on that last one we did. It was just going off the stairs. But and then the fall current health was 100, current armor was at 23.6. The fall damage was like 0.389, so it was a small fractional amount. If we scroll up here, that last we did a fall damage of 0 on this one, so nothing changed there. Fall damage 0. Anytime you jump, it's going to calculate the this information because you're essentially falling even though you're jumping. So it starts calculating that distance. In most cases, if it's under 10 meters, then it's 0 fall damage. Okay, that's why we took 44 here. So you can see how it's calculating, showing the distances. We started at a height of 227.98 meters here, and when it hit, the ending position was 173.9 in the y-axis. So it went down to when we hit, we're at 173 meters in the map. That's where that ground level happened to be, or that platform that we landed on. So it worked out really good. At first, it was when I first started working on the scripting for that. For some reason, it kept getting triggered or showing like immediately as soon as I jumped and the player would get in the air, it would show it right there. And so I was getting I was actually getting, for the most part, somewhat correct values, or what seemed to be correct. But after I got it sorted out and I have this data. This data actually pops up now when he actually hits the ground. Then it would show this data gets generated, and the numbers were a lot more accurate and consistent 100% of the time. So on the scripting side, like I said, we had this take damage before, but I took and all I had in there was this right here for the health. We subtracted the damage from the health. If health was less than or equal to 0, we set the health to 0, set player dead equals to true. I added a second function for the armor called take armor damage, and it does a similar thing there. Checks the armor, subtracts the damage from it. If the armor is less than or equal to 0, just make sure it can't go negative, so it sets the armor value at 0. And I also added for armor increase, a function called add protection. So if we were to pick up an item or drink a potion, whatever the amount of that value is for that potion, which I think if we use the bottled waters as a way to increase the armor, we might do like a value of 50, which is 50%, and it would increase it. So what I did was I modified, once I wrote that function down there, take armor damage, I had to add this little bit here of code into our initial take damage. I wanted to contain it here so that I could manage it all in one place, in one function. It's in the player manager script. If I didn't do it here, then I would have to be doing this kind of check in the script where the fall damage is occurring, and every time there was damage occurring, this code would have to be like all throughout our scripts. Every time there was an enemy that hit or another object that could cause damage, the same kind of checks would occur. So I just moved it in here, and you see it's doing an if check. If armor is greater than 0, meaning is there a value there, then if there is, then we create a temporary variable called armor damage, initially set it to 0, and then we're going to do a check because if the value of the current armor level, if it's greater than or equal to what the damage value is that's coming in, then we know that the damage is going to come, 100% of the damage is coming off the armor because it has more than sufficient value to subtract from it, and the armor value still be greater than or equal to 0 at that point. So what I do is I assign the damage coming into the armor damage variable, all the damage, and then set the damage thing to 0 here because we want to make sure that when it gets down to the health code, it's not subtracting anything from the health if all the damage is going toward the armor. Now, if the armor is not greater than the value of the current armor is not greater than the damage amount being inflicted, then it goes down to the else part. It doesn't do any of this. It goes down to the else, and again, it's a simple thing here. Then we assign, since we know what that's basically saying, if it goes to the else, what that's saying is that the damage amount passed in is greater than the current armor value. So what we can do then in that case, we know 100% of the armor or shield is going to be gone. So we assign whatever the value of our current armor is to the temporary variable called armor damage, and then we subtract armor damage from the damage value that was passed in, so we can adjust that down to the remaining amount of damage, that's going to be left to apply toward our health, which is going to take damage. And so that's how that works out. Inside this if armor call, this take armor damage is called with armor damage being passed in, because we're applying it to the armor at that point. And then down here is where we do the health, and we just subtract the damage. So now really all these functions are doing is readjusting or subtracting a value from the armor or the health, depending on what the damage coming in is. It's not reflecting in the UI at that point. All it's doing is updating these internal variables, health, which are and armor, which are represented by, we have a public variable called armor here. That's the one that's exposed outside this class, and it has a get property so that we can retrieve the value of what the current armor value is. Same with the all these are set up that way, but the two that we're using specifically are the health and the armor. We're going to be doing stamina here in just a minute to show you how this works and how to set up the UI object for that, the graphics and all that. And so the health, same thing. All we're doing is we don't have a setter. I commented that out. You can't set it outside this function. That's, the value is maintained internally through the take damage function. So we don't want to be able to have it set externally by any other part of the script, either on purpose or an error. And so with that said, and we also have our private variables for the fall distance, and that's all tracked in here as well. Initially these values are all set to 0, and then every frame is where we're doing this check here. Track falling time and distance. So, I added a new Boolean variable called bFalling inside our harvest globals. Now, bFalling is set directly from inside Invector, the Invector's third-person controller that we're using for our player as he runs. So, in their code, when they determine that the player is falling or when it hits the ground, I added a line of code or two in there to automatically flag our global to indicate the player is falling, and then it can be checked inside here easily without having to mess with their code. I'm trying to put as little modifications in the Invector code. I like to keep it the way it is in the event we need to upgrade and get another update from them. So all our code is done inside our player manager here for the falling. And so we got a couple of checks here. If bFalling set to true and the start fall time is equal to 0, that means this is the start of a new fall. And so we assign the current time to our start fall time variable, and we also get the starting fall distance, basically the distance that we're at, or the height really of our character at its character's Y position in 3D space. So, and we get that through the transform.position.y. This player manager script is actually attached to the third-party controller for Invector. So it can directly access, since this is a child directly of the main player object, the transform for it, we can just reference it right inside the script real nicely. And essentially this shorthand here where it says start fall distance equals end fall distance equals transform.position y, you read this from right to left, and what we're doing is assigning this value, whoops, undo that. We're assigning the transform.position.y to end fall distance, which then gets assigned to start fall distance. So it's a shorthand for combining two separate lines that you're taking transform that position at Y, assigning it to each of those separately. You can do it all in one line that way, because essentially they're all being assigned to the same thing, the end and the start. Now the end, of course, is going to change when the player hits. We're going to set the end distance and also set the end fall time at that point. So now keep in mind, this is called every frame as the player is falling at this point. We're in the game, it's just being called. So but you see, the only time we're going to execute any of this code is when B falling is true. So once he hits the ground and B falling is set to false, we no longer track this or execute this code. So it's only executed while in the falling motion or in the air. So the second check it does is, again, if we're falling and the start time is not equal to 0, which means there's a time that's been set for that. That means we've already started a fall. It's in motion, and so what we're going to do is we are going to continually, while he's falling, assign the new transformed up position at Y to our end fall distance. So we're tracking that every frame, until he hits the ground. It's constantly updating that every frame. So we got an accurate end fall distance. And then we have our final check here, which is when the B falling is set to false. We've got this exclamation here in front, which means not whatever the value this is, it's the opposite. So, and that's evaluates to not true. So if this is harvest close by falling is not true, meaning it's false, and our start fall time is not equal to 0. That's how we determine, because initially B falling is false to begin with in this game. It's going to be false. So this first part is true right off the bat. But this here is the key to making sure that it's only going to execute all this when we have an actual start time. So if the start fall time, as long as it's not equal to 0, then it knows that, okay, we're getting ready to wrap up our falling here, because it's B falling was set to false. We got a start fall time that's still set, which means we need to now calculate the ending data for this because the fall has completed. So the end fall distance, one last time, we get the current transformed up position at Y. We assign the end fall time as time.time, and this is where we're logging this data, the fall data. We'll get the start and end time, and then start and end Y position, which we've tracked that over here, the start fall and start fall time. So we push all that out to the logger, and then again do a calculation here just so I don't get my values mixed up whether I got the end distance or the fall distance. It's possible that if the map was developed in such a way that you have subterranean areas you can go into, which are under the, let's say, the base origin, 0, the XYZ at 0, 0, 0 in your 3D space. In my case, currently the map is everything's above, the Y value of 0, but potentially, the map could be modified where it's below 0. So in that case, you would get negative. You would get negative fall distance. And so to correct for that, basically what I do is I just do the calculation, the end fall distance minus start, and if for some reason it becomes negative, which means it could have been, you could have fallen in an area that was less than the origin of 3D space. We call the math.f.abs, which is the absolute function, which makes that positive number, so we can get back positive fall damage. And then I subtract this 10, which is our hard-coded value for the safe. Let's just put a comment there because I may forget why I did that. 10 is basically the safe file distance. So unless you're over 10, you're not going to take any damage. So as long as damage is calculated here, the distance is greater than 10, there'll be some fall damage. It should be positive, but if it's damage that happens to be less than 0 at that point, I just set it to 0 just in case there's an anomaly in the mathf function, ABS function. Anyways, and then we log out the current health, current armor, the fall damage, and then we pass the actual damage value to our take damage function that's in this player manager script. And then we also log out current health and armor so we can see how they were adjusted. So that's pretty much how the scripting goes. And then we, of course, have to reset all these variables to 0. And I just do it all in line with a single line instead of having each one on a separate line equal to 0. So we reset the start and the end fall time and the start fall distance and end fall distance. This way that wraps all this up, and that's how we know, since B falling at that point is set to false and our start time is now initialized back to 0, none of this code will execute until there's another fall. So that's how I implemented it. It was my version of it. It works. Another programmer may implement something different, but that's what I came up with, and it worked out good. All right, so that was really it on the scripting for the player manager, what we had modified. Now the quick slot bar that shows up in the middle of the screen on the bottom, we have this script here, and it's pretty simple. Essentially all it's doing is getting a reference to the we create a private class variable here for the UI player inventory manager, and we get that reference here with this line of code to the player inventory manager. Again, that's the script that has our a statically defined array of player items that the player has picked up. So that's where we're going to get this information from to load the quick slots with, based on what items are already in the quick slots. And so essentially it's just assigning each item we're only going to assign 6 specific slots in our quick slot bar that's on the UI. And what I did was we had a function called update item UI that was in our UI player inventory manager. I took that script and did a modified version of it and called it update QS item UI. And when I say modified, really the only thing that wasn't needed was we're not updating or showing the count of the stack count of the particular item in the quick slot. We're just showing what item is currently equipped there with no regard to the stack count. But I did think about adding an additional text field in our UI quick slot bar, and maybe in the lower right corner in smaller print will show, in definitely a different color, will show the actual count of items. So when you have, like, for example, first aid kits in a quick slot, 3, 4, 5, or 6, you want to be nice to know that you've got 3 or 4 of them there, because the way those are going to work, they generally give you a good amount of health increase. I think it was 80%, or 75, I think is the value we set up for that. 75. But if you use it, like when you've only lost 10 health and you hit and use one of those first aid kits, well, it's going to go ahead and use one up, and it's only going to increase by 10 because that's all you needed. If your shield and armor was, let's say your health was all the way up and your shield was at 90, if you hit one of those and use it, you're going to well, actually no, I think it said I was going to make the blue potion, so that would directly only affect your health. Your shields would have to be increased, and that's another thing we'll figure out. Do we want to maybe roll that over just to say first aid kits, But I think I'm going to keep it separate. I'm still going to, a first aid kit will recover health, and a blue drink water bottle will recover the shield aspect of that UI. Even though when you take damage, the shield is there to kind of protect your health. But when you take damage, if it overflows the shield value or the armor value, then of course it's gonna, the rollover or what's left of the damage will be subtracted from your health. So in that aspect, but I think as far as recharging your health and recharging your armor, it's going to be two separate items you would have to carry with you or find. And that's why it's good to stack those up. So if you had a stack of them, you might, if you knew that the reason I was getting at this is what I was trying to get at was, if you knew that the first aid kit gave you 75% health increase, well, you might wait until your health got down closer to like 25% before you hit it, so you can maximize its usage. Same with the shield. If the water bottles will bring up the shield by 50%, well, you'd want to wait till the shield looks like it's about halfway down before you actually use one, so you maximize the usage of that item. Again, that's up to you. If you've got a shit ton of them, if you're stacking up 30 or 40 of each, because right now there's no limit to the amount of items you can stack if they are a stackable item. There's not a weight system in place that prevents you by mass or weight from picking up too many of those items, so you could easily just use them and not worry about it. Essentially, I was going to keep it simple. Again, we're trying to just build this framework and get this game functioning and get through it all, and we could later go back and make some enhancements, like adding a weight variable to the backpack and things like that, or larger backpacks that you can find and that kind of stuff. At some point, maybe we'll actually have a backpack, you know what I mean, a visual backpack that shows up on the character as opposed to none at all right now. So yeah, there's a lot of things, but right now I'm working on the mechanics of the game and working on features and going through and just trying to implement some of the basic things that you'll see in most games. And I'll try to get the graphics to look as best I can. I'm not an artist or an animator, so I'll, in some cases I'll be trying to use what I can find for free on Google Images, and that's where I got really all the images for the UI right now. The health icon, the heart, and the shield, and I used GIMP to extract out and recreate the various images I need to make all this happen in the game to get it to work. Let me jump to that. That's the next thing I wanted to show. So we're going to add in the stamina. It's going to be the third one. If we go to the Unity here, and just I'm going to show you. If we click, first of all, if we go to sprites, see for the heart. The heart actually consisted of, well, initially I had this red heart here, but I got rid of that. I'm no longer using that. That was the original one before I had this one here. That's kind of, I created that off of this, but I was trying to get rid of this little, this is really supposed to be like a reflection spot, but what it really winds up being is an opacity area with no color, and sometimes the background shows too. But anyways, I wanted to clean that up, and I really couldn't get it cleaned up the way I wanted to, but I did manage to anyways use the heart the way it was, and the background was not transparent on this image I found, so I wound up having to go into GIMP and zoom into 400% and just use the free outline, select outline, and trace all the way around this heart image the best I could, and cut out the background to make it transparent. Hold on 1 second, let me check on the door. I think someone's at the door. Be right back. Alright, sorry about that. I am back now. Yeah, so yeah, I had to do some work with these images. So once I had the cutout done, then I had to make two variations. Basically, the way this works, when you're doing a what we call a graphical icon that has like a fill on it, and let me show you. If we go back to the health stat. Oh, sorry about that. Had a little distraction there. Okay, yeah. The way this is done is with three different images. You have your main image, which is going to represent we call the 100%, or this is going to be the fill image. And we're going to use a mask that will allow us to only show basically a portion of that fill image. So it's used to, and by using that mask, which is actually the same shape as the image, which is going to be a different color, it can mask out based on a value that's set what portion or percentage of that image is shown on there. And so, and of course, this other image here, the lighter pink one, is the background image that's shown. It's kind of it has a red, a flat red I took here, and then I brought down the opacity to 30%, so it had this lightness and this transparency to it. And so if we look at the health stat bar, the way it's constructed, it's an empty game object first of all on the UI, which basically gets a rect transform. Is on the UI, it's always a rect transform instead of a regular transform. And then you would then I added an image, which I named health icon, and I dropped that image in there. And yeah, I just created the image and I dropped it into the source image to make sure that's this one here, hard fancy big. And then what's important is to change the image type to filled. By default, it was set to simple, and when it's set to simple, you do not get these options here where you control how it's filled. When you say it's filled, then you can choose the fill method. Like, is it going to fill vertically? Is it going to fill horizontally? Are you going to do like a radial, just 90 degrees, which you can do a radial 180 or a full 360 radial fill. And based on a value you plug in, it controls how the fill is. So if I had said radial 180, well, we got it set for vertical. Let's leave it at that. And then fill origin, where does the fill start from? Bottom or top? So bottom is the default, and so meaning if you're at the bottom, like this kind of fill amount control. If you watch on the left there, if you look at my heart, you're seeing by sliding this down to 0, which is the fill amount, that's the origin, it starts at 0, the 0 amount, and you can increase it up to a value of 1. It's a fractional amount. And so there's some calculation that's done to basically take, in order to translate our, that's why I went with 100 on each of those, because I could easily divide the damage amount by 100 to come up with a fractional amount that comes up between 0 and 1, and then apply it appropriately to this. And you'll see where that's done. So yeah, that essentially the mask is just masking out what you see as this fill amount is going back and forth. Now the mask, you right click, once you add your image, you right click, and under effects, I'm sorry, no, 2D object, sprite mask, you add as a child object of your actual image that you're going to use for the fill, which is going to be like, what you want it to look like when it's 100% full, and what you're also going to use, by setting it as a fill type, vertical in this case, from the bottom, this slider, this fill amount value, they have a slider bar so you can see how it works, but you actually would change this in code, which is what we do. And so And then this last image here, health filled container. Really, it's just the background image that shows up as the masking as the fill value changes, the mask hides it. It hides basically the main image, and so you don't see it, and that's essentially how. And then it just shows what's behind it, which is this image here. So it gives that effect, like it's being filled or you're filling a container. And I did something similar with this one, but this one was a little bit different because if you notice, we have this silver outer edge, and so and we'll talk about that in just a second. But yeah, so that's the basic setup of the health stat as far as the imagery goes for the UI. Once all that's in place and you can see it working, by clicking your main health icon and slide this thing up and down. See, we could actually, if we went to, and I'm just curious about this radio 360. If we do that, it should go in a circular fashion like a clock. Yeah, see? We could have did a fill like that, if we wanted to. Which that's kind of neat too, actually. Show a radio. But I decided to keep it something really simple, vertical. And then same with the shield, that's vertical. Now, looking at the shield, you can see, like I said, I only used 3 images to make up that one. The shield I used 4. We have this one here, which is the background. That's what shows when the fill amount changes and it masks away the actual main icon image for it. It'll show what's behind it. That's kind of a transparent, blue shield. We've got the shield frame. This is the actual shield, the way it looks when it's full, 100%. And so these here and the mask, of course, is just a different color than what's in either one of these. The background, or really, it don't really matter about the background. It just has to be different than what's in the actual image that you're trying to mask out. And so it doesn't have to be any certain color. It can be any color you want. As you see, I used yellow just because it worked good in both cases. And so if we look at the armor stat, I labeled these a little bit different. As I figured out the first one, I decided to, since this is the filler, I call it filler. This is the filler image. This is actually an image, but it's the filler. And so, and then I labeled that shield BG for shield background, and shield frame that had a third image, the frame that went around it. See, without that, it would just look like that, and it would still work. Initially, I had it. See, when I first did it, I did it like I did the heart. So the frame was actually attached to the blue that you see right now. And so when I slid this thing down, I didn't realize the way the entire frame was going away as well. And it was just showing the translucent, blue background image there only. So what I wound up having to do is separate the frame from the middle portion of the image, and essentially create one like this, and then just this image is just put in there as a child of the armor stat. And so all 3 of these are child of the armor stat game object. The empty basically was the parent game object for this. And then of course we have a basic script, and I may have showed these scripts earlier. Yeah, armor stat. Maybe not. Essentially what it does is we declare a private variable called _img of type image, because that's the image that we want to manipulate the fill amount on. It's an image component. And in the initialization, which is the start function, it's ran one time for the script, we get a reference to this. And I'm using the find game object with tags, so make sure when you're doing this, if you're using the same similar code, you have to create tags, and we went over how to create tags before, but you have to create tags and assign those to the images. So if we go back here, for example, the filler image has this armor icon fill tag, and under the health icon I call it health icon, the same as the name here, but I did this one a little different. This will probably be the standard way I'll name stuff, just because it makes more sense. It's clearly, this is the filler image that's filling the your symbol here, but using the mask, it'll with the slider. So it made more sense to do that. But anyways, going back to the code, so we get that reference. Find a game object by tag, and then dot get component image, which is the image component of that that actual UI image game object. And so once we have that reference, then all we do in the update function, which is called once per frame, all we're doing is taking, making a call. We're referencing again, this armor is a public. It's been defined as a public variable. Remember, we had the get property that was set up in all these different variables we had in our player manager script. And so the player manager script is attached to our player object. And so we use the game object, that find game object with tag player. We only have one player that's ever out there in our game. And so we can get that armor value with this line of code. And then we divide it by 100. So keep in mind, again, our armor is based on a value of 100 up to 100 max. Our fill amount has to be a value between 0 and 1. So in order to convert a value that's 100, up to 100, you just divide by 100. That's made it real easy. We'd have to do something a little different if we had some kind of value that was greater than that. For example, let's say later on it makes it more complicated. Basically, we have to really think about it to get the code right. But if we had, let's say we started at 100 and we had this, well, if our armor was, let's say, up to 150, which was the max, so we allowed armor to be increased through levels and rank ups over time, and the armor can go higher than 100. Well, let's say our first rank up we got to armor of 150, and we had it maxed out and full, so the value of the armor was 150. If we divide that value by 100, that becomes 1.5 actually. 150 divided by 100 is 1.5. Well, the fill amount can only take a value between 0 and 1, and 1.5 exceeds that. So you'll probably get an error. Now Unity is good about, it'll report the error and it logs it out to the console. So when you're in the editor you can see it. But when the game's running, it'll just create that error internally. But it won't necessarily crash the game, it just won't do what you expect. Like, it will not set your fill amount properly. So, like I said, there's some additional code that would have to be designed to calculate and create the proper ratio and to get that a value between 0 and 1, because your armor could go even higher than 150. It could be maybe 250 at one point, then 500, then 1,000, especially like an RPG style game. So, simple dividing by 100 wouldn't work. It works fine here because that's what our value is. It's our max value is 100, so we just divide it by 100. It all works out great. I wanted to keep it simple just to get the functionality working. And so we've got one similar to this on the health as well. You can, except we're dividing the health by 100, and we're just setting the fill amount to that value. So, for example, if our armor was at 80, divide that by 100, that comes to 0.8. 0.8 is a number between 0 and 1.0. So we just assign it to fill amount. It sets the fill amount to that value, which automatically changes that. If you want to visualize it in the editor, it changes that slider. We can slide that down and get it to like 0.8 is right there. So it would lower the health. So we're basically controlling the fill amount. This here is, we've got a visual slider here in the inspector, but you're not really adjusting the slider in. The slider is adjusting the value that's in fill amount, and that's how it uses it in the script to mask off the excuse me the image. Yeah, so essentially that's how it's done. So let's turn our shield background, the frame. Let's check that back so we do have it. And so by doing that, it's just, you know, changing the inner portion. Looks like it's filling the shield that way. Kind of a neat effect. So there wasn't really much to it. Now we're going to do something similar. We're going to be working on, like I said, the stamina. Let's get that rolling. We've been streaming for a little while already, just going over the changes that I've already done. So I want to add the stamina as the last one, and to show what the stamina is. And then we'll write some code. Now once we show what our stamina is, then we're going to write some code that will, you know, modify that stamina value. Because by default it's set to 100 when the game starts. And now we talked about we're not going to have unlimited stamina. Stamina, well, we did say that's what the blue bottle was going to be. I think we're going to use it for increasing stamina. So we'll have to come up with something. It may be that stamina recharges over time. A lot of games do that. You don't necessarily pick something up. It's something that, as your player essentially rests by walking, he'll build up a slow amount of stamina back. And so we'll probably do something along that lines. And it will slowly recharge the stamina over time up to a maximum value of 100. But as you sprint, you'll be using your stamina as you go. So we'll work on that change. Let's work on adding the UI element right now. We'll get that portion of it added. Well, before we do that, we need our graphics. We don't even have our graphics made. So I can show you the process that I was going through before. Let's see if this will load up in GIMP. Alright, so we're going to do File, we're going to Open, and what I'm looking for this may be our folder. Let's go to